Welcome to MOVITRAC LTE-B Plus Basic and Intermediate Training. This is Session 7. In this session, we're going to cover a number of miscellaneous topics. We're going to look at a number of different parameters available in the MOVITRAC LTE-B Plus that configure various specialized operations. We're also going to talk about faults, how you can identify them, how you can deal with them, how you can find out more about them. So let's go ahead and get started. We're going to start by learning how to configure two outputs available on the MOVITRAC LTE-B Plus. These can provide status information to external devices like controllers and PLCs. They can also control devices. We're going to see how you can set these up and different ways in which you can use them. There are two output signals available on the MOVITRAC LTE-B and the MOVITRAC LTE-B Plus. There is the AODO signal. This is a combined analog and digital output signal. It can be one or the other. Obviously can't be both at the same time. When you configure it in analog mode, it outputs a voltage between 0 and 10 volts. When you configure it as a digital output, it operates at 24-volt digital logic, meaning when it's logic 1, it's outputting close to 24 volts, and when it's logic 0, it's outputting close to ground level. So that's one signal. The other is the relay contact. There is a small relay inside the MOVITRAC LTE-B and B+. It's a simple single contact relay, and it has fairly restricted electrical parameters, but it's very useful and can be used as an output device as well. We'll look at both of these. We'll learn how you configure their behavior. Let's start with the relay contact. The relay contact can provide status feedback to a controller, like a PLC, for example. Here's how you would do that. If you had a typical PLC, what you would do is you'd connect the PLC's 24-volt supply to the relay reference input, and you would connect the relay contact output to one of the PLC's 24-volt digital inputs. As long as you're using the PLC's power supply, then everything will work just fine. The PLC will be able to detect that contact opening and closing. That's one thing you can do with the relay. So it's sort of really a digital output in this form. You can also use the relay contact to control an external device, for example, some kind of indicator. If you did this, you would have to provide your own power supply because remember the built-in 24-volt supply in the MOVITRAC LTE-B Plus is not a high current supply. You would need to connect up an external supply through the relay and it could power the device. Just as a refresher, we've talked about this before. Here are the electrical specs of the relay. You can go up to 250 volts AC at 5 amps maximum or 30 volts DC also at 5 amps maximum. So respect those requirements and you'll be just fine. And then finally, a third thing you can do with the relay contact is control a brake through a brake controller. We talked about this several sessions ago, how to wire up the BMK brake controller. So this is just a review, but you would connect up a 24-volt supply to the relay, and then you'd connect the relay output to the BMK brake controller. The brake controller would also have to be connected up to appropriate brake power, and it would have to be wired to the brake on a brake motor using the red, white, and blue connections. So that's your basic setup, and the relay can control the brake indirectly through the brake controller. Just a reminder, I gave you this warning in the past, but I'm going to just give it again as a refresher. Although the MOVITRAC LTE-B and B Plus can work with the brake, they must never be used for hoist, vertical, or angled applications. They are not appropriate for that. Those would be unsafe. So they're meant to be used for horizontal type applications where the brake is not a safety feature. If you need something more like a hoist application, you might wish to take a look at the MOVITRAC LTE-P, which is perhaps a better choice. All right, warning over, let's continue. So how do you configure the relay to operate these different devices? Well, you go to parameter 18 in the extended parameters. That configures the relay behavior. It determines when the relay closes, when the relay opens. By default, it's set to 1. Which is a status signal called drive healthy. What will happen is the relay contact will be closed if the VFD is ready to operate, and it will be open if something's wrong with the VFD. So it's basically a VFD ready signal. But as you can see, we have other choices here. Some of these are status information, and some of these are what we call comparison operations. We'll talk about both. I will point out that option 8 is only available on the MOVITRAC LTE-B+. It is not available on the regular B, but all the others are available on both of them. The first 4 of these, 0 through 3, indicate some aspect of the VFD's status, whether it's enabled, whether it's healthy, is the motor at a target speed, and is the VFD in a fault condition. So what will happen with these? The relay contact will close when the condition is true. Let's look at an example here. Drive tripped. If we set parameter 18 to 3 and the VFD is normal and not in a fault condition, the relay contact will be open. On the other hand, if the VFD is faulted, the relay will close and signal that fact. Now, what are these other choices all about? These are what we call comparisons. They open or close the relay contact depending upon whether the motor's speed or the amount of current it's drawing is above or below a limit. So you have to define a limit, and then the VFD will do a comparison. The limit is a percentage of either the motor's maximum speed, which is stored in parameter 0.1, or the motor's nominal current, which is stored in parameter 0.8. So you have to provide a percentage value. The VFD will then do that comparison. The relay contact will close when the comparison is true, and it will be open when it's false. So where do you enter this limit percentage? Well, to do that, you go to parameter 19 in the extended parameters, and you put in a value. It defaults to 100%, but you can change it, and you see it has 1 decimal place, so you can do a fraction of a percent as well. Let me give you an example here. Let's say we want to watch for the motor's speed falling below 450 RPM, assuming the motor has a maximum speed of 1800 RPM. How would we configure the relay to reflect this? Well, first thing we would do is we would pick option 6, where the motor speed is less than a limit, because we're looking for it to drop below the limit. Then we'd have to calculate what 450 RPM is relative to 1800 RPM, the motor's maximum speed. We do the math, it's 25% of 1800 RPM. We would program parameter 19 to 25.0%. And what would happen in that case if the motor's speed is greater than or equal to 450 RPM, or 25%, the relay contact will be open. However, if the motor speed drops below 450 RPM, which is 25%, the relay contact will close, indicating that condition is true. So that is how you use limits to reflect status digitally. All right, so what do we do if we want to control a brake using the relay contact? How do we do that? There are several possible ways to control a brake, and I strongly emphasize be sure to test the system thoroughly to confirm the desired behavior. We're sort of getting brake operation through the back door by using a brake controller. So you do have to do some testing and experimenting to make sure everything is working correctly. I'm going to show you 2 different ways you can control the brake, and I'm assuming you have a BMK brake controller wired up as I've shown you in this session and in the earlier one. All right, here's one way. You can set parameter 18 to 0. What that means is the relay contact will close every time the drive is enabled, and it will open whenever the drive is not enabled. So what will happen is when you enable the VFD, the relay contact will close, which will cause the brake to release. I'm going to give you a little caution here, though. Depending how you've set up your VFD, it might not be developing any torque at that point when the brake releases. So it is possible for the load to move without the brake holding it in place. So remember, always be safe. The brake must never be a safety feature. You need to be aware that this could happen and make sure that your application can handle that safely. When you disable the VFD, the relay contact will open, and that will engage the brake and hold the motor in place. All right, so that's one way. Here's another way. You could select option 4 for parameter 18. That is a comparison using a limit, so of course you have to set a limit in parameter 19 as well. Notice it's set to a mere 1%. What this combination will do is it will close the relay contact when the motor speed is greater than or equal to 1% of the motor's maximum speed, which is stored in parameter 0.1. The idea here is that the brake is going to release when the motor has started to turn and the speed has just climbed above 0. Now the way this will work is kind of interesting. You'll start the VFD, and of course the brake is holding the motor, so the brake keeps the motor from turning, but the VFD will start to rotate the magnetic field inside the motor. As soon as that rotating speed gets to at least 1% of the motor's maximum speed, the comparison will become true, the relay contact will close, the brake will release, and the motor will actually start to turn. Later on, when the motor slows down, when its speed drops below 1% of the maximum, the relay contact will open, engaging the brake. So what you may have to do here is play with that limit a little bit in order to get the brake to release and engage at the right time. Okay, so that's the general theory behind this. Now, a few notes that I'd like to give you. First of all, you may have to experiment with the limit value to get the desired brake behavior. That limit value determines when the brake releases and when it engages relative to the motor's speed. So feel free to experiment with that a little bit until it behaves the way you want. I'll also mention you may wish to experiment with different ways to stop, either the coast to stop mode or the ramp to stop mode, which is set in parameter 05. All right, moving on, we're going to go to our second output signal, the AODO signal, the one that can be either an analog output or a digital output, and we'll look at how you can use it. Now, in digital mode, the signal provides feedback to some kind of a controller that has digital inputs. For example, if you had a PLC with 24-volt digital inputs, you could connect AODO to one of those inputs. Don't forget to connect the PLC's signal ground to one of the 0-volt terminals so that it's at the same reference level. Otherwise, you may not be able to sense the signal correctly. So that is one thing you can do. In analog mode, the signal provides a voltage representing a process value. So for example, if you configure it in analog mode and connect it up to some kind of a meter, like an ordinary multimeter, and you connect the multimeter's ground lead to one of the 0-volt terminals, you can monitor speed, current, or power. And this will be represented as a voltage. Just a note here, power is only available as a monitored parameter on the MOVITRAC LTE-B+. It is not available on the MOVITRAC LTE-B. Now, what you would probably do in actual life is not use a multimeter. You'd probably connect up a PLC with analog inputs. But if you want to experiment with this, I suggest you connect a multimeter up to it and play with it. Let me give you an example here. The analog outputs between 0 and 10 volts DC. That corresponds to 0 to 100% of one of those three parameters. So in our example here, 6.75 volts equals 67.5%. If the value happens to represent speed, for example, and parameter 1, the maximum motor speed is 1800 RPM, a voltage of 6.75 volts corresponds to a speed of 1215 RPM. You can work out the math if you're curious about it. It's a simple percentage calculation. So that is how the AODO signal can be used. So how do you configure it? You go to parameter 25 in the extended parameters, and that configures the AODO signal's behavior. The default value is 8, and these are the choices. The first 8 choices are identical to the relay, which is set in parameter 18. You can see we have various status values, and we also have some comparisons. So these work exactly as they do with the relay. But the last 3 are process values, and these are analog signals. The previous ones, 0 through 7, are digital, 8 through 10 are analog. So you'll get voltages if you pick any of these. You can see the default is motor speed. So I think it's time to do a demonstration. Let's play with the relay, and let's play with the analog digital output. All right, well, we're going to do a little experimenting with setting up the relay to tell us different things about what the VFD is doing. Now, I've been doing some experimenting with my VFD since our last session, so I've been changing parameters. What I need to do first is set up my VFD to be appropriate for what we're going to do. So the first thing I'm going to do is enable real-time edit mode. Remember, you never want to forget to do that, because otherwise you'll change parameters and then they won't actually change. I'm on my basic tab here. I need to do a few things to get us ready. First of all, I'm going to change my acceleration ramp time to 5 seconds. I want a longer ramp time for this activity. I also want to be in terminal control mode, not keypad mode. So I'm going to change to 0, terminal mode. I'm now going to go to the Extended tab, and we're going to change some extended parameters. First thing I'm going to do is change my terminal control variant from 3, which is what I was playing with a few minutes ago, and I'm going to change it now to 0, which is what I want. So digital input 1 is going to be the stop run signal. Digital input 2 will control forward or reverse. Digital input 3 will select between the potentiometer and preset speed 1. And the fourth input is an analog input. It's going to be connected to the speed control potentiometer. So that's good. Now I'm going to change my preset 1 speed here. I'm going to change it from 100 RPM to 900 RPM. My motor is an 1800 RPM motor, so by changing it to 900 RPM, I'm setting it to 50% of the motor's top speed. Do remember that number. It's going to be relevant in just a few minutes. All right, so now we have our VFD configured, ready for our activity. We're going to play with the relay. So that means going to parameter 18. Now you notice that parameter 18 right now is set to the default drive healthy. So the relay will close whenever the drive is ready to run. It will open if the drive isn't healthy. In other words, it's not really ready to run. The first thing we're going to do is we're just going to use the relay to give us a status value. So I'm going to pull this down and I'm going to pick option 2, motor at target speed. Now what's going to happen is whenever the motor reaches the target speed, whatever we request, it's going to close, and when we're not at the target speed, it's going to open. So what I'm going to do, I'm going to enable my VFD by turning digital input 1 on, and I'm going to select preset speed 1. I'll do this by turning digital input 3 on, and that's going to pick 900 RPM. What will happen is the VFD will accelerate from 0 to 900 RPM. It will take several seconds to get there, and once it reaches that target speed of 900 RPM, the relay contact should close. Let's see if that's what actually happens. I'm going to exit real-time edit mode, and I'm going to change to monitor mode so we can watch what the relay is doing. So I pick the drive monitor tool up here, and notice that I have the relay picked as a monitorable parameter. Remember, we can pull this down and monitor a variety of things, so I've got it set to relay. Now I need to enable real-time monitoring, so I'm going to click Enable Real-Time Monitor. And we can see it's telling us the drive is stopped. It's also telling us the relay is open. And notice you can also see the 4 digital inputs there. I'm going to go over to my VFD and flip some switches, and I want you to keep your eye on the digital inputs and on the relay output as I do it. Also watch the motor speed, which is on the left side there, right next to stopped. What you're going to see, you'll see the motor accelerate, and when we reach 900 RPM, the target speed, you should see that relay close. Let's see if that actually happens. Here we go. All right, you can see that's what actually happened. I turned digital input 3 on to select the preset, and then I turned digital input 1 on to start the motor running. It accelerated, and when it reached 900 RPM, the relay contact closed because we were at target speed. Now what I'm going to do is I'm going to switch digital input 1 off, and that's going to bring the motor to a stop. You should see the contact open almost immediately. And that is what happened, just as we expected. Okay, so that's one thing you can do with the relay. Let's disable real-time monitor, and let's go back to the parameters. And I'm going to re-enable real-time edit mode. And let's try something else. Let's play with a limit. So I'm going to pull this down, and I'm going to pick option 4. The relay contact will close if the motor speed is greater than or equal to a limit. So let's pick this here. Now the limit is set in parameter 19. Right now it's set to 100. Let's change it to 50%. So what's going to happen is when we enable our VFD and we start the motor turning, the VFD is going to monitor the motor speed, and when it is greater than or equal to 50% of the motor's top speed, in other words, when it's greater than or equal to 900 RPM, the relay contact should close. When it falls below that speed, it should open. What I'm going to do is I'm going to run the drive in potentiometer control mode, and I'm going to turn the knob very slowly. And what you're going to do is watch the relay contact and see at what speed it closes. So let's disable real-time edit mode since we've made our changes here, and let's go back to monitor mode. And I'm going to enable real-time monitor. And what I'm going to do now is I'm going to turn digital input 3 off, so I'm in potentiometer control mode. Then I'm going to enable the VFD by turning digital input 1 on, and I'm going to slowly turn the potentiometer knob. And you can watch the speed on the screen, and you can also watch the relay contact, and you can see when it clicks. Here we go. Okay, you can see that the speed is ramping up gradually. I'm doing this slowly so you can see when the relay clicks, so keep your eye on the speed and the relay, and it'll click in just a second. Click. Okay, that worked as expected. As you can see, when we got to 900 RPM, the relay contact closed because it was greater than or equal to the limit value we set. Now I'm going to slowly turn the knob down, and you're going to see the relay open as soon as it goes below 900 RPM or 50%. Here we go. Okay, and you can see that it opened as soon as we crossed 900 RPM once we drop right below that. Let me stop my motor. And we're going to disable real-time monitoring. Now I'd like to show you something extra. This is a feature only available in the MOVITRAC LTE-B+. It is not available in the regular B, but this is a rather handy feature. It's designed to eliminate what's called relay chattering. Now think about this. Remember, our relay contact closes at 900 RPM, so if I turn that knob just up to 900 RPM, maybe a little beyond it, the relay contact will close. If I turn it just slightly below it, it will open. But what if I have my value right on the line, right at 900 RPM, where maybe it's jumping back and forth between 900 and 899? What's going to happen is the relay contact will start to chatter. It will open and close as that value drifts slightly. That could be very annoying or even problematic. So it would be nice if the relay wouldn't be quite so sensitive. Now we can reduce its sensitivity by adding something called hysteresis to it. That's a slight lagging behind value that will cause the relay not to open instantly when it falls below 900. It will actually have to drop slightly further than that before it opens, and that can eliminate chattering if you're too close to it. Now this is something, as I say, that you can only do on a MOVITRAC LTE-B+. It's a parameter not available on the older VFD, but let me show it to you here. We're going to go back to parameter mode, and we're going to re-enable real-time edit. We're going to scroll down here to parameter 50. User relay output hysteresis. Now this is a percentage value. And what you're going to do here is you're going to enter a percentage. This is a percentage of the motor's total speed. That will be equivalent to an RPM value that will indicate where the relay should reopen. Now remember, our relay is triggering at 900 RPM, which is 50% of the motor's total speed. Let's say we want to adjust the VFD so that it opens at 10% of the motor's total speed below 900 RPM. Now we can do the math here. We have an 1800 RPM motor. 10% of that is 180 RPM. So if I set this value to 10%, what will happen is the relay won't reopen until we drop down to 720 RPM. That's 900 RPM minus 180 RPM. So I'm going to put 10% in here. And now I'm going to disable real-time edit mode and go back to monitor mode. Okay, I'm going to enable real-time monitoring again. Now watch very closely. I'm going to start the VFD. I'm going to turn the knob up, and you'll see that when we reach 900 RPM, the relay contact will close. I'm then going to turn it backwards, and you'll notice instead of reopening as soon as it drops below 900 RPM, it won't open until we get to about 720 RPM because we've added that 10% hysteresis. Here we go. Okay, the speed is ramping up. We're heading toward 900, the point when the relay should close. So we're getting there, almost there, and click. Now we'll come back down. Notice we haven't reopened yet. We're not going to reopen until we get to around 720. When we get to 720, we should open, and there we go. Now you notice when I took my hand off the knob, it jumped up to 743, but notice the relay didn't reclose. It's not going to reclose until I go back up to 900, and that's what we want. So by adding that little hysteresis window there, we keep the relay contact from chattering. So that is a handy feature you can take advantage of if you have a MOVITRAC LTE-B+. Unfortunately, if you have an LTE-B, you can't. You'll just have to put up with chattering in the circumstances that cause it to occur. Okay? Just something to be aware of. Anyway, that's the relay contact. All right, let's change directions now. We're going to look at the second output that's available on the MOVITRAC LTE-B+ and B. That is the AODO output. Remember, this can be either an analog output or a digital output. I'm going to disable the real-time monitor and go back to the parameters. Let's take a look at how the AODO output is configured. Remember, this is parameter 25. Now, right now, it is set to an analog mode. It's set to motor speed. So remember, it can either do the same thing you can do with the relay. These are the digital outputs here. And then we have analog outputs here. Motor speed is the default, and that's going to be an analog output. So we're going to get a voltage representation of our motor speed. Actually, let's just keep this. Let's not change it. Let's just go ahead and see how this is going to behave. All right, so I'm not changing anything actually. So I'm going back now to my monitor mode, and I'm going to enable real-time monitoring. And what I'm going to do, I'm going to go to potentiometer control mode. So what I will do is I will turn digital input 3 off. That will switch to potentiometer control. I'll turn digital input 1 on, and I'm going to just ramp the drive up. Now I've connected a digital multimeter to the analog output and to ground. As we ramp the speed up and down, you'll be able to see the voltage change in response to that. All right, you can see what's happening. You can see that as I turn up the speed, the voltage is increasing. I'm going to try to stop as close as I can to 1,000 RPM. 1,000 RPM is about 56% of 1,800 RPM, the motor's maximum speed. That should give a voltage of about 5.5 volts. And as you can see, we're pretty close to that. So this is just an analog representation of the motor speed. It's a voltage that a PLC could monitor. Now what I'm going to do is now go back down to 0 and then come to a stop. So there we go. All right, now we're going to move on to a new topic. We're going to talk in a little more depth about VFD faults. Now, I've talked about faults on a number of occasions in several sessions. I've talked about some specific faults, but I'd like to now talk about this topic a little more formally. We'll talk about some of the most common faults that can come up with the VFD. We'll also talk about where you can get more information about them. Now, of course, as you know, when things go wrong, the very first place you tend to look is the keypad on the front of the VFD. The 7-segment LED display gives you a kind of limited text message explaining what sort of error occurs, and after a while you'll get experienced interpreting these. And then, of course, also the keypad is the place you go to clear faults. You do this by pressing the stop button, which will clear the fault, and if the original condition is now gone, the VFD should be able to restart at this point. Now, I've mentioned this before, but I'm going to mention it again. You should always be cautious when you clear faults because the VFD often will just immediately restart as soon as you clear that fault. So never clear a fault unless you're really sure it's okay for the VFD to start. If you're concerned about it, you should disable the VFD in some way before clearing the fault if that's necessary for safety. Now, how the VFD behaves when you clear the fault depends upon a parameter that we haven't talked about yet, but we'll be talking about shortly in this session, parameter 30. This parameter determines how the VFD handles the fault being cleared. Does it restart immediately or does it do something else? But I would say this, in the interest of safety, always be safe by assuming that when you clear a fault, the VFD could restart immediately. Now, let's look at a few of the common faults. Of course, there are many different faults that can come up, but many of them don't happen very often. So I'm going to talk about the ones that I think are the most likely that you'll be seeing fairly frequently. We've covered this one before, the external sensor trip. As you know, you can assign one of the digital inputs to an active low external fault sensor. If that sensor goes low, then the VFD will halt and you'll get the E-trip message. So this one can come up if you have a sensor installed. A closely related one is the motor protection trip. Now this one will only happen on the MOVITRAC LTE-B+. It does not happen on the regular B, which does not have this fault message. The B will simply use the external sensor trip for motor protection, but if you have the B+, then you will see this FPTC fault, and that just indicates that a temperature sensor connected up to a digital input has faulted. So that will let you know that the motor is overheated. You'll need to let it cool down. You'll need to correct whatever caused it to overheat, and then you can restart the VFD. So E-trip and FPTC are similar related errors. OT indicates that the heat sink, in other words, the power electronics, have overheated. What this means is that the IGBTs, which drive the motor, have had too much current through them for too long, or they haven't been able to cool down sufficiently. Maybe they have restricted airflow or something over the heatsink. Whatever the case is, they have overheated and the VFD is shut down to protect them from damage. So if this happens, you need to figure out why they overheated. You need to possibly check the airflow, you need to check the motor, you need to see if there's an overcurrent situation, and possibly you need to consider changing the pulse width modulation frequency. Maybe it's operating at 16 kilohertz. You may need to drop that to a lower frequency to see if that will help. So there are a number of reasons why you can get overheating. These three faults are all related to excessive amount of current through the VFD or an overload situation. So any one of these can come up in those conditions. There are many reasons that you can get overcurrent or overload conditions. The motor could be stalled or the application jammed in some way. It's also possible that you are simply trying to ramp too rapidly. Overcurrent conditions come if you try to change speed or direction too quickly. So if you take a look at this and you say there's no reason we should be getting an overload, check your ramps. Check if you're accelerating or changing direction too rapidly. And if that's the case, adjust those ramp values and hopefully the overcurrent or overload condition will go away. It is possible, if you've got a brake resistor on your MOVITRAC LTE-B or B+, that it has been overloaded in some way. In other words, you're getting too much regenerative energy. This can happen if the load is driving the motor as a generator and it's generating more current than the brake resistor can dissipate. In that case, the VFD will shut down to protect it. So if you see this, see what your application is doing and see if you can correct that problem. The DC link overvoltage condition is caused by the motor acting as a generator, and it is generating more energy than the DC link can handle, so you have an overvoltage situation. If you have a VFD without a brake resistor, this can happen because there is no way to dissipate that regenerative energy. So if you see an overvoltage situation, you need to take a look at your application and see if something in it can be altered or corrected. DC link undervoltage happens all the time. Whenever you shut off the VFD by cutting its power, this message will flash briefly before the VFD shuts down. That is actually not a fault, it's just normal. But if this happens during operation, what it means is for some reason the DC link voltage has dropped too low, possibly the line voltage has sagged. Whatever the case is, you need to investigate it and correct it. These are some of the common fault messages you'll see. There are certainly others, but I think these will cover many of the typical fault situations. Now, where can you get more information if you have a fault situation come up? Can you obtain more information than just the message on the VFD's keypad display? The answer is absolutely. There is a wealth of information available, but to do this, you need to dive into LT Shell, connect up to the VFD, and scan into it, and that will give you a lot more information. Let me remind you, when you go into LT Shell, don't forget to enable real-time edit mode, and then check the refresh boxes of any parameter that you wish to monitor. Otherwise, you are looking at static information that was obtained when you scanned in to the VFD. So let's look at some of the things that are available in LT Shell. You need to go to the P00 tab. Don't forget the P00 tab only appears if you enable the extended parameters by putting a 101 in parameter 14. Once you do that, you'll have the P00 tab and you can go in and examine some of the read-only parameters. First place you might want to look is P005 and 09. These two parameters show the temperature of the internal electronics and the power electronics. Both of these can overheat, so it's worth looking at these. Another good place to look if you're doing diagnostics is the DC bus voltage and the DC bus voltage ripple. These parameters show you the condition of the DC link part of the VFD. A lot of problems manifest themselves on the DC link voltage. So the DC bus voltage should be about 1.4 times the maximum motor output voltage. If you have a 115 volts single phase VFD, it actually outputs 230 volts, so it has an internal voltage doubler. The DC bus voltage should be about 330 volts. If you have a 230 volt VFD, either single or three phase, it should also have a DC bus voltage of about 330. If you have a 460 volt three-phase VFD, you should see about 650. If you see anything significantly larger or smaller than this value, then something is going wrong. Either you're having a situation where there's too much regenerative energy being pushed back into the VFD, or you have something that is overloading the DC link and causing the voltage to sag. So if you see any significant deviation, definitely cause for concern. If you see excessive ripple on the DC bus ripple parameter, this value should normally be very small. If you see a large value, it means that the filter network isn't able to keep the DC bus smooth. And if that happens, the VFD can start to malfunction. It probably means you've overloaded the VFD in some way. So check those two things. They're very good places to spot problems caused by power difficulties. And then finally, I'm going to point out that a number of key parameters in the P00 tab are actually logs that hold the last 8 values associated with a fault. Now here's one right here, P0-15. That's the DC bus voltage log. It shows you the last 8 values of the DC bus after a fault. So you can kind of look back at the history and see what's been going on. Here are some other logs. There's ones that monitor the power electronics, and they give you its temperature history. That's telling you the temperature of the power electronics, the IGBTs, the heatsink. Motor current log shows you the motor current that's been drawn before fault situation, so you can see how much current was being pulled at the time of a fault, and that can be extremely useful. Now these next parameters, P0-18, 19, and 20, contain information about the VFD itself. If you have to make a technical support call, for example, to SEW Eurodrive Regional Engineering, they may ask you for information like, what firmware version are you running? What specific MOVITRAC LTE-B Plus do you have? Maybe they'll ask you for your serial number. You can obtain all this information right here in these parameters. So if you're on the phone and you're getting help, you might need to provide this information, so be ready to go to it if necessary. Parameter 0-28 is the trip log. It contains the last 4 VFD faults with a full text description. Very useful. You can use this information to see what's been going on recently with the VFD. The DC bus ripple log is another one of those logs with 8 values in it, showing you the most recent 8 fault conditions, so you can see what the DC bus ripple was like under those conditions. The internal drive temperature log shows the temperature of the internal electronics, which is separate from the power electronics. So you can look at this and you can see if your VFD is overheating internally. There are a number of counters which keep a tally of critical faults, so you can look at these. You notice in this example, P0-35 is the under voltage count. You notice it's 46. You might be tempted to think, boy, this VFD is having a lot of problems. The answer is no, it isn't. Remember, you always get an under voltage when you switch off the VFD. So there are going to be a lot of them in that particular counter. But if you're seeing a high count that accumulates rapidly during normal operation, then that could indicate something serious going on with your power supply. So these counters can be very helpful too. All right. So that's faults. Now let's transition to something related to faults that we need to talk about, and that is startup and restart behavior. Now remember, I have warned you on a number of occasions that your VFD can restart without warning when you clear a fault. And I've said you always have to be careful about that to prevent accidental injury or other problems. Well, it's possible to configure the VFD to behave in a number of different ways when you clear a fault. It's also possible to configure it to behave in different ways when it's powered up. So we're going to talk about both of these right now so you can get your VFD configured correctly and also safely. Let's begin by looking at the VFD when it's operating in terminal control mode. We're going to look at how it starts up in terminal control mode and also how it handles restarts. This applies when parameter 12 is set to 0. That selects terminal control mode. Now, to set the behavior itself, you need to go to parameter 30 in the extended parameters. This determines how the VFD starts and restarts when it's in terminal control mode. By default, it's set to what's called auto 0. Now, these are the available choices here. Auto 0 is the default. What is auto 0? Well, this is what we've been seeing when we've been playing with our VFD. In this mode, the VFD will automatically start if it's enabled when you power it up. So if your enable signal, which is digital input 1, is on, when the VFD powers up, it will automatically start. So always be aware of that. By default, the VFD will tend to start upon power up if it's enabled. That can be dangerous, of course, if you're not expecting it. So do be aware of this, especially since this is the default behavior. When you're in auto 0 mode, the VFD will also automatically restart if you clear a fault. So if the fault is gone, you clear it, the VFD can immediately start running. So be aware of that. It's very important to be conscious of this since auto 0 is the default behavior. Now, what if you say, I really don't like that, I feel that's unsafe for my application? Well, there's a good alternative to it, and it is this one right here, what is called Edge R. When you're in this mode, the VFD will not start or restart unless it sees a rising edge on the enable signal. That's digital input 1. So if digital input 1 is on, when the VFD is powered up, it will not automatically start. You will have to turn that off and then on again to produce a rising edge. Then the VFD will start up. If you have a fault and you clear the fault and digital input 1 is still on, the VFD will not restart until you turn digital input 1 off and then back on. So if you want to have that extra level of safety, change to mode 0 Edge R, and then the VFD will not tend to restart automatically. Now, what's auto 1 through auto 5? Well, this is a version of automatic restart, but what it will do in the case of faults is that it will automatically attempt to restart after a fault. You won't have to clear the fault, in other words. The VFD can be unattended and it will attempt to restart. Now, auto 1 will attempt 1 time, auto 5 times, so each one has progressively more times it will attempt to restart. What I'd like to say here, and this is very important, use caution when you're in any of the auto modes, because the VFD can restart automatically, and in the case of 1 through 5, it will make these attempts at 20-second intervals. So the VFD could possibly restart sometime later automatically. Be conscious of this, always be safe. Okay, so that's terminal control mode. I think it's time for another demonstration. What we're going to do is see how the VFD behaves when we're in terminal control mode, and we pick different startup and restart modes. Now, one of the things we're going to explore is how the VFD behaves after you clear a fault, so we need to be able to generate a fault on command. We're going to use the external fault sensor connected to digital input 3. That's the easiest way to trigger a fault, so we need to pick a variant that supports that. Let me turn real-time edit mode on. Now I'm going to go up to parameter 15 and I'm going to pick variant 3 because variant 3 supports an external fault sensor. You can see it's right there, trip run on digital input 3. That's all we need to do. Of course, I need to flip the switch on digital input 3 to the on position so the VFD won't trip the minute I enable it. Notice that parameter 30 shows us the mode we're in for terminal control. We're in auto 0. That means that the VFD will start running immediately if it's enabled when you power it up, and it also means it will restart automatically if you clear a fault. This is its default behavior, by the way, so this is the way it will normally behave. All right, here's what I'm going to do. I'm going to first of all turn my VFD off, and then I'm going to turn digital input 1 on, in other words, enable it. I'm going to leave digital input 2 off. That will select the potentiometer control. And I'm going to turn the potentiometer knob all the way up to the top, 1800 RPM. I'm then going to flip on my VFD's power. And what you will see is that it will immediately start running. It will ramp up to 1800 RPM without warning. This is auto zero behavior. It will start upon power up if it's enabled. Let's do that. Okay, we'll turn DI3 on so we don't get a fault and turn the potentiometer all the way up, and we'll enable the VFD, and now we're going to power it up, and you notice it starts up immediately as soon as you've powered it up because it's enabled. Let's trip a fault. So we'll turn DI3 off, E-trip, turn it back on, and now clear the fault, and notice the VFD immediately restarts when we clear the fault because it's still enabled. All right, we'll turn it off by disabling DI1. All right, so no surprises there. It works exactly as we expect it to work. Now let's change it to mode 0, which is the Edge R mode. This is a mode that I consider a little bit safer because the VFD is not going to automatically start when it's enabled, when it receives power. It's going to have to see a rising edge on digital input 1. Also, when you clear a fault, it will not automatically restart. Again, you will have to have a rising edge on digital input 1. So I'm going to now disable real-time edit mode. Okay, now what I'm going to do is turn my VFD's power off, wait for it to switch off. I'm going to do the same thing. I'm going to have the potentiometer turned all the way to the top. I'm going to have the VFD enabled, and I'm going to switch it on. And this time you will see the VFD does not start. I will have to take digital input 1, turn it off, and then back on in order for it to start. So that gives it the rising edge. And then I'm going to trip a fault by turning digital input 3 off. As soon as that happens, I'll turn it back on, and I will clear the fault, and you'll see this time the VFD will not restart automatically. The fault will clear, but nothing will happen. And then I will have to again create a rising edge in order for the VFD to restart. Here we go. Okay, we'll enable the VFD by turning DI1 on and power it up, and notice now it does not start up. It's waiting for that rising edge, which I'll give it, and there you can see it starts up now. Now let's trip a fault, turn DI3 off, E-trip, then back on and clear it. Notice it doesn't restart. Again, it's waiting for a rising edge on DI1, and when I give it to it, then it restarts. So Edge R is clearly quite different from Auto 0. Let's turn it off by disabling DI1. Okay, I think you can see the difference between Auto 0 and Edge R. They both have their place, they're both useful, and it's important to pick the one that works best for your application and gives the safest response. So there we go. Let's look at another mode you can be in, and that is in keypad mode, when you're being controlled by the keypad on the front of the VFD. How does it behave then? Well, parameter 31 in the extended parameters determines how the VFD starts and restarts when it's in keypad control mode. That's when parameter 12 equals 1 or 2. We've looked at that mode as well. By default, the choice is 1, but these are the available choices. Choices 4 through 7 are only available on the MOVITRAC LTE-B+. On the MOVITRAC LTE-B, only 0 through 3 are available. We're going to look at just those because these others are more specialized. Now, when you're in keypad mode, remember there are actually two ways of starting the VFD. You can start it by pressing the Start button on the keypad. And remember, there's a kind of shadow restricted functionality terminal control mode in the background where you can use switches connected up to the digital inputs. And so these choices work either with the Start button or with terminal control mode. So if you set parameter 31 to 0 or 1, then these will affect how the VFD behaves when you press the Start button. If you pick 2 or 3, it will control how the VFD behaves if it's started by the switches. Now, if you pick 0 or 2, the VFD will start to run at the minimum speed programmed in parameter 02. Now, if you've set parameter 02 to 0, then you're not going to see much action on the VFD, but if you have a non-zero speed in there, the minimum speed, that is what the VFD will go to by default when you press the Start button or trigger it by switches. On the other hand, if you pick 1 or 3, the VFD will run at whatever the last speed was that it operated at before it was stopped. And of course, do be aware that if you start it up and you activate one of the control switches, or if you're pressing the up and down keypad buttons on the keypad, the speed could change very quickly depending upon what you're doing. So that is keypad restart mode. I mentioned fire mode several sessions ago when we talked about terminal control, and I said it's a feature only available on the MOVITRAC LTE-B+. So I do want to tell you a little bit about it so you know what fire mode is for. The name is kind of interesting and you may be intrigued by it. What is fire mode? It's an emergency operating mode in which the VFD runs at a fixed speed that can't be interrupted easily. You trigger fire mode through terminal control mode. There is one variant, variant 13, which activates it. When you signal that you want fire mode, it immediately begins to run at a fixed speed, and from that point on, it ignores set point changes, it ignores faults, and basically it just keeps running and running and running, either until you shut its power off or until it's physically destroyed. The idea here is that the VFD is running some critical system that is necessary to keep running as long as possible in an emergency. For example, in an actual fire, maybe it's some kind of a ventilation system that has to keep running. The idea is you don't want the VFD to shut down. So that is what fire mode is. And as I've said, it's only available for the MOVITRAC LTE-B+, so don't look for it on the regular B. So how do you set up fire mode? You use parameter 12 in the basic parameters and parameters 15 and 60 in the extended parameters to configure fire mode. So you set parameter 12 to 0, that just activates terminal control mode. You set parameter 15 to 13, which selects the terminal control variant that you want. Only 13 supports fire mode. And then parameter 60, which defaults to 0, is the fire mode speed. So you'll need to set that to whatever speed you want it to go to when you drop into fire mode. Let's look at the variant itself so you see how the digital inputs behave. All right, it's variant 13. Digital input 1 is the stop run signal, as it is usually. Digital input 2 selects between either the potentiometer for speed control or preset 1. Digital input 3 is where the action takes place. This selects between fire mode and normal mode. So if there's a 0 here, you go into fire mode, and if there's a 1, it's just normal operation. And then analog input 1, digital input 4 is the speed control potentiometer. So let's look at some of the combinations you can do here. If you have an off on digital input 1 and an on digital input 3, that is a normal stop. So your normal operation, you'll get a normal VFD stop using the ramp and parameter 4. If you have an on in digital input 1, an off on digital input 2, and an on digital input 3, you will run with potentiometer speed control. If you have them all on, you'll run at preset speed 1. That's the speed in parameter 20. And this is the exciting one, fire mode here. If you have digital input 1 on, digital input 2 doesn't matter, but digital input 3 off, you will enter fire mode and you'll run at the speed stored in parameter 60. And as I said, you really can't interrupt that mode very easily. Turning off the VFD is the best way to clear fire mode. And then finally, one miscellaneous topic, and we are done with this session. I mentioned this way back in the beginning. We talked about the IP66 version of the MOVITRAC LTE-B+ and B, and I mentioned that those models come with a built-in speed control potentiometer and control switch, which can select between directions or a neutral position. What if you don't want to use those controls? What if you want to wire something else up to the I/O connector and control the VFD? What can you do about the built-in controls? Well, they can be selectively disabled on the MOVITRAC LTE-B+ through some parameters. So if you want to connect something else up and disable those, here's what you need to do. All right, this little table here shows you all the possible combinations. You can have the potentiometer activated or deactivated. You can have the clockwise switch activated or deactivated. And you can have the counterclockwise switch activated or deactivated. There are 8 possible combinations of all those different controls. We call these set 1 through 8. So by picking one of these, you can deactivate everything, activate everything, or something in between. Now, where do you go to make this change? Well, here's what you do. First of all, you have to have your extended parameters activated. So parameter 14 needs to be set to 101. Then you go to the P00 parameter through the keypad. You press the stop button until set 1 appears, which is the default setting, everything activated, and then you pick set 2 through 8 to deactivate something selectively. And then finally, when you're done, you press stop again to accept, and you're all set. So that is how you can control the built-in controls. What if you have a MOVITRAC LTE-B rather than a B+? How do you do it there? You don't do it with parameters. You do it in a much less sophisticated way. You need a screwdriver. So you need to open up the VFD so you can get into the I/O connector. You notice there are 2 wire harnesses that go there, so you just physically disconnect the controls that you don't want to use. The wire harness on the left connects to the switches. The wire harness on the right connects to the potentiometer. So simply remove those from the connector, and there you go. You have disabled them. So a little less high-tech, but easy to do nonetheless. And we are now finally done with session 7. That was a rather long session, but we had to cover just a lot of miscellaneous topics. So hope you found that helpful. In session 8, we're going to look at a very interesting and useful tool built into the MOVITRAC LTE-B and B+, something called the scope. It is very useful for confirming VFD operation, for tweaking it to the application, or for diagnosing hard to figure out faults. So that is what we're doing in the next session. I'm looking forward to it. I hope you are too. See you then.